Hi there. We looked today in class at 5 basic constructions: constructing a congruent segment, constructing a congruent angle, and bisecting an angle, along with constructing perpendicular lines and parallel lines. When you look at these 3 worksheets, there are some more challenging advanced constructions. For example, on this one, number 7 was constructing a square with sides the length of AB, and constructing isosceles triangles. And during this video, I'm not going to go over those advanced constructions. I'm going to focus on those 5 basic ones. Okay, so number 1 and number 2, we are asked to create lines equal to A, B, and CD, or construct lines equal to 2 CDs. And to do this, we're going to start by drawing in a long line. This line is going to end up getting cut into pieces, one piece equal to the length of AB, one piece equal to the length of CD. And so to find that length, I'm going to take my compass and I'm going to set it so that it's congruent to or equal to the length, the distance between A and B. Okay, and so I'm going to take my compass, put 1 at A, and I'm going to move my compass so that the pencil is located at B. Okay, as you can see here, my compass is set to be AB. And then I'm going to come down here, I'm going to put my marker at my endpoint, and I'm going to draw in a portion equal to the length AB. Okay, and then we're going to do CD as well, so I'm going to do the same thing with my compass, only this time setting it equal to the distance between C and D. Like this. And then same thing, go ahead and put your marker on the endpoint and mark an arc for CD. Okay. And that segment, where it ends there, from my first endpoint to where I just ended, that second endpoint, that segment is equal to AB plus CD. Okay, number 2, we're going to do 2 CDs. They have the same steps. So we make our compass set to CD, and we go ahead and mark CD and CD, 2 CDs. And so these 2 are how we construct congruent segments. Okay, to construct a congruent angle, number 3 and number 4 involve constructing congruent angles. And so to construct a congruent angle, we start with drawing in a ray. The ray we're drawing in is supposed to be this bottom ray of our original angle. Okay, but we don't need to worry overly much that this is the same length as that. It's a ray technically, so this arrow means it goes on forever. So it doesn't matter if they're the same length or even if this has the same exact slope as this one. We're going to be building an angle off this ray. All right, so how do we build the angle? Well, it starts with drawing an arc on the original angle. Now that arc can be of any width, so the width of my compass right now is currently set at this width. Okay. And so I'm going to go ahead and put my marker here and draw on that arc. Okay. But I could have technically done a smaller or larger arc. It does not matter. I just need to have drawn in some arc so that I have 2 intersection points. Now with that same distance, that same width of my compass, I'm going to come over here to my copied angle and I'm going to draw in the same arc. Unfortunately, I only have 1 intersection point with this one because I'm missing the second ray. Okay, and so then the last step is going to be to create that second intersection point, the one I'm missing over here. Okay, and the way we do that is we take our compass and we set it equal to the distance between our 2 intersection points. So I'm going to go ahead and loosen this up. I'm going to make it equal to the distance between those 2 intersection points. And then I'm going to come over here and I'm putting my marker on 1 intersection point, the one I have. I'm going to draw in the second one, the one I'm missing. So again, it's the distance from the marker, or sorry, from one intersection point to the other. and come over here and make that second intersection point. Now that we have it, we can connect it to my starting ray and create the vertex of the angle. That's how you copy an angle. Okay, so repeating the steps one more time, because 10.1b are these same constructions. So if you're wanting to just practice, I'd be looking at my 10.1b, practicing those on my own, referencing this video to help me if I get stuck on something. Okay, there's my original ray. And again, doesn't matter if it's at the same slope as this one or the same distance. I think I actually made this one the same slope, but I didn't have to do that. I could have drawn that ray here, and it wouldn't have mattered. Okay, and so then I'm going to draw in an arc. The arc can be any distance. So I'm going to put my marker of my compass here on the vertex of the angle. And I'm going to draw in that arc. So that I have two intersection points. And then I'm going to copy that arc over here. I'm going to put my marker on the vertex and copy that arc. Okay. So then the last step, because I only have one intersection point, is to create a second intersection point, and that comes from measuring the distance between the two intersection points of my original angle. And I always double check my measurement after I've tightened my compass, because every once in a while it slides a little bit. It looks like I'm good to go. Okay. So then I come over here, put my marker on the intersection point, draw in the second intersection point, and I can connect the ray. And so that's the second basic construction, copying an angle, constructing a congruent angle. Okay, the third basic construction is to bisect an angle. Okay, well, to bisect something means to cut in half, or to cut it in half, right? So we're going to be cutting the distance between the two rays of my angle. I'm going to be cutting this angle in half. And so if it's cut in half, that means the distance from my ray, my first ray, to that, the degree measurement, I should say, the degree measurement from my first ray to that bisector, and from that bisector to the second ray should be equal. That ray should be halfway in between. Okay, and so that's how you construct a bisector, is to find a point that is halfway between. Okay? Well, the first step of constructing a bisector is to have an arc across your angle, and that arc can be of any width, and we did that originally when we were copying the angle. And so we can utilize that arc. If we didn't have an arc, we'd draw one in, just like we did when we first started copying the angle. Again, the width of that arc doesn't matter, but you need to have an arc so that you have two intersection points. Okay, once you have two intersection points, you can set your compass again at any width, right? The width doesn't matter. And we're going to find an equidistant point. So when I put my marker here on the end point, okay, and I draw in a piece of an arc, and then I put my marker here on the other end point and draw in a piece of an arc, where those two arcs touch, this location is equidistant between those two rays. And so when I connect that point to my vertex, I have a bisector. The angle has been cut in half. So out here, draw in your arc, and again, this arc can be any distance. If for some reason you draw the arcs in and they don't touch, well, it probably just means your compass is too small and you need to make it wider, right? It means you've made your distance too small if the circles, if the arcs don't touch. You just need to make the arcs wider. And that intersection point connected to the vertex, and we have a bisector. Same with over here. two arcs, and you have your bisector. Oops. I noticed there with that one, when I drew those arcs in, okay, that my first arc doesn't quite touch my second arc, but it's going to, so I just need to put my marker back over here and extend that arc. And that's the third type of construction, bisecting an angle. Okay, the fourth type of construction is to bisect a segment, or to create a perpendicular line to a segment. We have what's called a perpendicular bisector, which accomplishes both. Perpendicular bisector both allows us to draw a perpendicular line as well as to bisect a segment, right? And so this is what we're going to be utilizing here. So with number 5, we start with copying AB, which we've already looked at how to do that, up in number 1 and number 2. So I'll go ahead and start with my long line. I'll set my compass to be equal to AB. Okay, like that. And then we're going to come down here and draw in our arc, AB. Okay, so now that I have a segment, AB, I can bisect that segment by drawing in a perpendicular bisector. To draw in a perpendicular bisector, you start with making your compass so that its distance, its measurement, is more than half the distance between A and B. Right? If you do forget that step and you make your distance less than halfway between A and B, your two lines, or your two arcs that we're about to draw in, they won't intersect. And so that'll remind you, oh yeah, I need to make my compass so it's more than halfway between A and B. When we do that, we then draw in semicircle here. And it doesn't have to be a full semicircle, but you want a good piece of arc. Okay? And then you switch the compass to come over here and draw in a second arc. And again, you want a good chunk of the arc. So if you want to do a full semicircle, you can, or again, just make sure it's enough that you end up with 2 intersection points. Because those 2 intersection points where the 2 arcs touch is going to be the perpendicular bisector of the segment AB. Okay? Okay, so if we turn it over then, number 6, the last one that we're going to do on this, again looking at that perpendicular bisector. Okay. Over here on number 5, we constructed our AB by copying it. Okay, well, sometimes we're going to be just straight up given the segment, so then there's no constructing of the segment necessary. You literally just do your bisection here, your perpendicular bisector. You draw those 2 arcs in and connect them at their intersection points. Okay, but sometimes when you aren't given the segment to begin with, and sometimes when you aren't even given a segment to copy, then you need to define a segment, right? You need to find a spot where you can put in your perpendicular bisector. In this case, number 6, we're drawing a line perpendicular to MN that passes through P. We're still going to be using the steps of a perpendicular bisector, but here's what I was talking about, where we need to define that line, that segment. The segment that would make a perpendicular bisector through P. Or that would get a perpendicular bisector through P, I should say. Okay. And so we do that by taking our compass, and again, we can set it at any width. and tighten it. The only key with this is we need our compass, when I put my marker on my point P, we need our compass to be able to touch that line twice to create two intersection points. And so my first attempt there, my compass didn't quite touch the line, so I'm going to make my compass a little wider. Oops. Okay. Well, when I put my marker on P, I can find a point where it touches MN right there. And because this compass is set at a specific distance, then I know that this point will be the same distance from P as this point made on the other side. That my A here and my B here are equidistant, or the same distance from P. Right? And that's going to allow that to be bisected through P, because I know they're the same distance from P as it is, so if I bisect AB, it's going to go through P. It can create a perpendicular bisector there, and that'll create a line perpendicular to MN. Okay? Well, we already talked about how to do a perpendicular bisector, but let's look at it one more time. Now that I have my section, my segment AB that I know will get bisected, and that bisector will go through P, I need to construct it by taking my compass, setting it more than halfway between A and B. Okay, like that. That's more than halfway between A and B. And I can draw in my arcs, my semicircle. And I'll come over here, do the same thing over here. And when I connect those, I get those two intersection points. I get my perpendicular bisector. Through point P. Sorry, the perpendicular bisector, I should specify this. That is the perpendicular bisector of segment AB, not of MN. But because it's the perpendicular bisector of AB, I know it's also perpendicular to the line MN. Because it comes in at a 90-degree angle. Okay, so then you have a worksheet 10.1b that is uploaded on my website that you could work through for extra practice of those four constructions. So again, at this point we have done constructing congruent segments, constructing congruent angles, bisecting angles, so that's 3 of them. And the last one here was constructing perpendicular bisectors. Okay. And perpendicular lines. Okay, so the last one will be constructing parallel lines. And so to build us into this idea, I'm going to review one more time perpendicular. And so if you'd like to fast forward through the video, if you're feeling like you're getting the perpendiculars, feel free. We're going to do 2 more practices here. So one more time looking at one that's directly from the line, one with a point off the line. Make sure we've got that 4th construction down. Okay. So here we go. We're creating a line perpendicular to AB. Right? So I'm given a segment here, and so I'm going to create a perpendicular bisector by making my compass more than halfway between A and B, like this. And so once I've done that, I can do my semicircles, or the close to a semicircle, and connect those 2 intersection points. And that is my perpendicular bisector. Number 2, we're asked to draw a line perpendicular to CD through point P. Right? And so we need to define our AB. We need to define 2 points for ourselves so that we can draw in a perpendicular bisector of those 2 points that make a segment, and that perpendicular bisector will go through P. So I'm going to set my compass here at some distance. Again, that distance doesn't matter. This is the distance I've chosen. I'm going to put my marker on point P, the one that I'm trying to go through, and I'm going to draw in 2 points that I know are equidistant, are the same distance from point P. Because if they're the same distance from point P, my new A and B will have a bisector that goes through P. Okay. So now that I have A and B, I can make sure my compass is more than halfway. Check. Draw in my semicircles. Check. And connect the two intersection points of my semicircles to make a line perpendicular to CD. Okay. Last but not least, we have creating parallels. So this is the 5th basic construction. And we can construct parallel lines a couple of different ways, but the way we discussed in class is the one that's built off of the constructions we've learned thus far. The one we looked at in class is how to create parallel lines using two perpendiculars. Right, so we're going to start with this by drawing in a perpendicular, just like we've just reviewed above. We're going to make our AB. So there's my A, my B, okay, and then I can do my perpendicular bisector, making sure that it's more than halfway between AB, and drawing in those semicircles. And connecting those endpoints. And when you do this, you're going to want to make sure you go through that point. You want excess line over here because we're going to be doing another perpendicular bisector. So make sure you go all the way through that point. Okay. Well, now that we've done that, we're going to reorient our paper because we're going to do another perpendicular bisector through point S. So I'm going to turn my paper here because now I'm going to be looking at this line, the one I just drew, and I'm going to do perpendicular to that. And so just like we did before, we're going to define an A and a B for ourselves. Okay. And so we're going to set our compass at some distance, put our pointer on S. Compass is a little wide, so I'm going to make it a little bit smaller. Put my pointer on the point I want to go through, right, through point S here. Okay. And I'm going to make my A and my B. And then I'm going to make sure my compass is more than halfway, which right now it's only halfway, so I'm going to go ahead and lengthen that to make it more than halfway. You know, that gets pretty close to all the way, so I might bring my compass in just a little bit. It's not quite so close to all the way. All right, so there's more than half of the way. And then I'm going to draw in my two semicircles. 1 and 2. And when you connect those endpoints, it should go through S and be parallel to our original segment. Okay, so again, parallels are just two perpendicular constructions. Okay, turning it over, doing one more. Number 4, creating a line parallel to RS through point T. I'm going to start with defining my AB. So I'm going to widen my compass a little bit here. Oops, that was a little bit too wide. Bring it back in. So there's my A, there's my B. And then with my A and my B, I'm going to construct a perpendicular bisector, more than halfway. Semicircle. And when you connect those intersection points, it goes through point T and is a perpendicular bisector of segment AB. And again, go through T. Make sure you go past point T because you're going to do another AB line. or another set of AB marks, I should say. Okay, so we're going to set our compass to draw in another AB. So pointer at the point I want to go through, which in this case is point T. So pointer at point T, draw in one segment and the other segment. So there's my new AB. And then I can do a perpendicular bisector to segment AB, more than halfway. Whoops, that went all the way. Make that a little bit smaller. Just want to go more than halfway, check. And then we draw in our semicircles. And when I connect those two intersection points, I get a line that goes through T and is parallel to my original segment. Okay, so one more time, the 5 basic constructions that you are responsible for at this point in the unit are: 1, constructing congruent segments; 2, constructing congruent angles; 3, bisecting angles; 4, constructing perpendicular bisectors; 5, constructing a parallel line.